Good afternoon. We are continuing with our functions and we're going into the graphing part of it. So we were working on those function tables and being able to set up function tables. Now we're doing CO47. I can identify the domain and range of a relation. So we're going to see what domain and range mean, what a relation is, and what the domain and range are. So we need to get some definitions down so we can really start to understand how we're going to do this math. A relation is a collection of ordered pairs that you use in a function table or a graph. So think about those function tables we just talked about and think about how we have ordered pairs for our graph. So that is the relation. So it's the collection of ordered pairs. Our domain are the x values of a relation. Any wild guess on what the range is going to be?
The y values of
The y values of a relation. So when we talk about a relation, we're just talking about those ordered pairs. And remember, our ordered pairs are x, y. So the domain are all of the x's, the range are all of the y's. When we have that function table, we have multiple ordered pairs listed in there, right? So when we look at that relation, you have that whole collection of ordered pairs. Like your function table, you have that collection of ordered pairs that we would take out of our function table. The input side, the output side, the x, the y. So we are going to discuss relations in two forms. Write the domain and range of each. So we have it as the table, and we have it as our graph. So when we look at those function tables that we just worked on it with our last objective, we had our input and our output. So you can think of your input and your output. Now instead of saying B for batches and V for vanilla, we're saying the input is always the X, the output is always the Y. So we have our X and our Y. So let's think about what would be the domain of this function table. Emily. So tell me the actual domain of this function table.
-5, 2, 4, and 0.
So you would just list them like that. So when it asks for that domain, you're just listing them. So our x we know is the input. That is our domain. Our range is the output, which is the y. So if I'm going to write my list for my range, what am I going to put? James?
-3, 0, 8, 2, -1.
So when we have a function table, we have specific x's and y's. These are our ordered pairs. Because I could look at my input and my output, and I could say this is -10, -3. This is -5, 0, because I know my x's and my y's. Right? So the function table is pretty easy. We know what our x's are, we know what our y's are, because we can take the x and the y out of that function table and put them as an ordered pair. But now we have our coordinate plane, where we're graphing lines. And now it gets a little bit trickier, because we don't have specific points on the line. We just have a whole line drawn. So it's not quite so easy. But look at what we do. Our domain, do we know specifics? James?
It's the X values.
It is the x values. What are the x values for this line? Think about what we know about lines. See how we have our arrows here? What do those arrows mean on a line? Gus?
Straight, so go for a while.
Go just for a while?
I mean, so the line keeps going.
It keeps going. Those arrows mean it's going to go on and on and on. We know that the middle of our graph is 0. These are all positive numbers going this way. These are all negative numbers going this way. So that means it could be any number would be on that line, right? So it would be, we call it all real numbers. And there's a symbol we're going to use for all real numbers, and it looks like this. Looks like two lines with an R going over them. So I'm going to write it up here. Not pi, because pi has that curve on the top. So it's not pi.
TR kind of.
Kind of looks like a TR. The way I make it is I do my two parallel lines, my straight line over the top, and make it into an R. That means all real numbers. So, because we know our line goes on and it goes on all the way through all of the negative numbers, all the way through all of our positive numbers. So we just say our domain for this line is all real numbers. So all you would have to put is that symbol. Chris?
Why would there be a T if there's no T's in?
Because it's not actually a T. It's just a symbol. It looks like a T next to an R, but it's not. I'm guessing it stands for real. I just know this is the symbol. I can't tell you exactly how they chose that to be the symbol, but that is the symbol for all real numbers. So now let's look at our range. Is our range specific numbers, or is it go on and on and on and on? What do you think? Are they specific numbers for our range for the y? Or does it keep going on? What do you think, Chance? Which specific numbers would be our range?
Between -1, 7, -1, 7, and 5, and then 5, 1.
So 5, 1 would be here. -1. Nope, we're still on this one. We're still on our line. Emily? So what would our range be for this line?
I don't know.
Alexis?
Isn't it the same?
Same being what?
Oh,
Because does our line ever stop?
no.
No, so it's going to go all the way down through those y's. It's going to keep going down. It's going to go all the way up. It's going to keep on going. So our range is our all real numbers again. When it's that line and it doesn't go straight up and down or straight across, it's hitting every single number. Now we're going to look at our segment. Does our segment go on forever?
No.
No, a segment is different than the line. The line has the arrows. Our segment has a starting point and an ending point. It is important to note the difference between the line and the segment, because your answers for the domain and range are going to be very different. So now our domain is going to start at what point? What's the x that it's going to start at? Because domains are the x's.
Five.
We always read from left to right.
Oh,
So you want the smallest number to the biggest number. What is our range, our domain going to be?
7.
Is 7 our x? Aiden, look at our x-axis if I'm reading from left to right, what is that first x that I get?
1.
Careful. It's gonna be -1. Now, it might not be the easiest to always see those negatives on your graph, but you know where the x and the y cross over each other are 0. So you know to the left of 0 on the number line are negatives, to the right are positives. When you're going up and down, going up is positive, going down from 0 is negative. It's super important that we remember those negative numbers. So we start at -1, because we could go all the way up to our line at -1. Then I'm going to draw a little arrow saying I'm going to start at -1 and I'm going to go across to what number for my x's, James?
5.
5. Because I'm going to go up from 5 and that's where my segment stops. So my domain is -1 to 5. So that word 2, I'm going to use that arrow in there. So that's going to help us know how to write our range. How would I write the range for this segment? Now I'm looking on the y-axis. So now I'm on the y for my range. I'm going to read it from the top down just because we're starting at the left and we're going to the right. So I always start at the left point. So if I start at the left point, what is the beginning of my range? I only have one person who knows. Who knows what the beginning is? Mario.
7.
Oh, you know what?
1.
I said we start at the left and we go to the right, but I'm looking at this and I'm saying we start with the smallest number. So that was my bad on how I just explained it. So Mario, going based off of that, what's the smallest number we're going to start at? 1. So we always start with our smallest number and then we go to our bigger number. So it doesn't matter which point is on the left and which point is on the right. You always want to start with your smallest number and you go to your biggest number. So that's why we have the arrow is always going to go to the right. So 1 is our smallest number. What is our biggest number going to be? Tatum? 7. So for the domain on the x, we always start on the left because that's always going to be the smallest. As you read going to the right on the x-axis for that domain, it's going to get bigger. For the range, for that up and down, you start with the smallest number and it goes to the biggest number. It depends on which way our segment is going. Does that make sense? All right. So I'm going to scroll up so we can see. We're getting towards the bottom of my board here. It's kind of hard for people. So on the bottom of this page, we have segments and we have lines. How do we know if it is a line? James? If it has arrows at the end, you know it's going to continue on and on. If it is a segment, it just has a start and stop point, no arrows. It's just going to have a start and stop. It doesn't have the point on it. It's just that part of a line with no arrows. You know that's a segment. So if we look at this first one, there's no arrows, so we know it's a segment. So you have to write the domain and the range for each of these. Okay, so that's what we have to write for it. There is a second page to this. James, you have a question about this?
Yeah. So for the arrow one, I only do the symbol.
If it's all real numbers. So remember, are we going to have all real numbers with the segment? No. The only time with a line that it wouldn't be all real numbers is if it's a line that goes completely up and down or completely across. Why couldn't we put all real numbers, Tatum?
I think it's because like it keeps going through. It's still parallel, like the same.
Because it's going to be the same number, right? So if we're looking at this one, if we did it straight up and down, our domain on that x is just going to be -2. It's not going to be any others because it's just -2 for our x up and down. So we couldn't put all real numbers. If it's straight up and down or straight across, you would have to put for your domain or your range, which one is always going to be constant. We don't have any of this on this side, but I just wanted to point that out. If you don't have those, if it is slanted, if it is a slanted line, it will always be the all real numbers, if it's slanted. Gus?
For the range?
For the other one, it would. So for that example, you're right, Gus. If I went straight up and down, the domain would be -2, but the range would be all real numbers, because it always goes up or always goes down. So, and if it was the one that went across, well, let's not do -2 again. It's the one that goes across like this. Our domain would have been all real numbers, and our range would have been that 1. So only one of them would be all real numbers, the other one would be a constant. But if it's slanted, then they're both the all real numbers. So let's look at our second page. Because this one I think you can finish on your own. Now we're going to make an XY table or a graph with the given domain and range. So let's see how that works. You look confused, James.
Oh, no.
Okay, so what I'm going to do to help myself out is I'm going to remind myself that my domain equals the x's, oh my. And so the domain equals the x's, the range equals my y's. So that's just my little notes to myself to make sure I remember and keep them straight. So it's always a good idea to put those on the top of the page so you don't have to keep flipping back and forth. So now we're going to either do a function table or we're going to do a graph. How are we going to know if we're going to do a function table? What gives it away, Tatum?
Just like the normal numbers or
Yeah.
specific
When we
numbers.
have specific numbers listed, we know it's going to be a function table. So we would put our x and our y, a function table like yesterday, yes. So then you fill in your x's. They match up. Shh. So we would have -4 first, so my y would have to be 3. Then I have -1 to -4, and then my third for each is 6 and 6. And I have 0 and 10, 2, and -1. So we're just going to do those function tables when we have specific coordinates that we can plug in. And they go in order. So see how we matched them up. Our first ones are our x and the y, then we have our next xy, the next one, and the next one. So now our next example is not specific numbers. So that tells me I have to graph it. I do not need to put all of my labeled numbers out on the graph and make all the grids. I can keep it simple like this. I know this is my 0. And I know my domain, my x's are going to start at -3 and go to 5. I know my y's are going to start at +2 and go to a +4. So I can look at that and say, we have a -3 to where we're gonna start. And if I remember my quadrants right, my first quadrants are gonna be positive, positive. Positive x's to the right, positive x's go up. My second quadrant are when my x's are negative, but my y's are still going up, so those are positive. Quadrant 3, x is negative because it's going to the left, y is going down, so our y is negative. And then our quadrant 4, I have my x's going to the right, so they're positive, but my y's are going down, so they're negative. So if I keep that in mind, what each quadrant is, as I look at this, I know where my starting points are going to be. So this is just information that we know. So for the quadrant 1, the quadrants are always the same on any graph you have. This is always quadrant 1, this side is always quadrant 2, down here is always quadrant 3, over here is always quadrant 4. So that's something that if we didn't know that, we're learning it today. Okay, so when we look at our graphs, we have 1, 2, 3, 4. We did talk about this when we did graphing at Christmas time with the Grinch. So I did mention this already. We're just coming back to it. So now, do you guys understand the positives and negatives? So we've got our number line, so that helps us with our positive and negatives. So keeping that in mind, it's going to help us know where a negative 3, 2. So this coordinate is negative 3, 2. Where would that be on this graph? So I'm going to look at that and say, well, if it's negative 3, it's going to go to the left a little bit, not a lot of ways. It's going to go to the left a little, but it's a positive 2, so it's going to be about right there. It doesn't have to be precise, but we do want to label it negative 3, 2. So then I'm going to look at my second ordered pair, would be 5, 4. So I'm going to go over 1, 2, 3, 4, 5, and up 4. Then I'm going to label it, this is 5, 4, and then I'm just going to connect my segment. How are we feeling about the segment? Is there anybody who's kind of, some of us are being honest, saying, oh, nope, we're a little shaky. Let's look at the one right below it, because I can see that's another one that has the range, right? So, first thing we do is we draw a graph. Then I'm going to look at where my starting point is. It's a positive 1 and a positive 2. So that means my coordinates are 1, 2, and then to end it, it's 4, 5. So how would I graph that? Which quadrant am I going to be in if they're both positive? James?
Number 1.
I'm going to be in quadrant 1. Both of them are going to be in quadrant 1 because they're both have positive, positive, and positive, positive. So I'm going to go to 1, which is going to be close to the 0. I'm going to go up 2. So I'll put 1, 2 as my starting coordinate. And then I have to go to 4, 5. So if this was 1, I'm going to count over 2, 3, 4. Then I'm going to go up 5. 1, 2, 3, 4, 5. And then I just connect it. So you're just trying to count over, or count up or down the same spacing. Like I said, it doesn't have to be precise. Just as long as you put the starting coordinate and your ending coordinate, and you know if you're going to the left or right, if you're going up or down. Emily.
What do you do when there's a whole bunch of numbers like in the game? I like that.
I didn't.
No,
If you have specific numbers, it's gonna be a function.
No, I can't add that one. The one below the one we just did.
That's the function table, 'cause it's
These are your
specific
Monday
numbers.
afternoon announcements.
So,
Player, you are
For that, we're gonna say to our friends at home, we hope you're well. We hope to see you soon. Have a good day.